So welcome, my name is Steven Feuerstein. I'm the PL SQL Developer Advocate at Oracle, otherwise known as the Developer Advocate for PL SQL. And I have that job because I've been doing almost nothing but writing about and playing around with PL SQL since about 1991, which has its strengths and its weaknesses. So for example, usually on my office hour sessions, I'm joined by Chris Saxon, who is one of our developer advocates for SQL, which really means the entire database. And he helps me plug in my holes of knowledge around anything outside of PL SQL. So for today, he can't join me. So therefore, if we have questions outside my bailiwick, PL SQL, like any non-trivial SQL questions, maybe folks who are on the chat can help because they probably know SQL better than I. So what I'm going to talk about today is bulk processing in PL SQL, probably the single most important performance area in the PL SQL language. And as usual, what I'm going to do is run through the basic elements of the features, not going into too much detail, relying heavily on live SQL for all the scripts I've already published there that you can go and look at later. And then we'll move into questions as quickly as possible and conversation about your experiences with bulk processing with FORALL and BULK COLLECT. I do encourage you to follow me on Twitter, SF_on_PL_SQL. You can contact me directly via my email as you see on this page. Follow my blog, YouTube videos, lots of resources out there for PL SQL and Oracle database developers. So let's see, first of all, before we dive in, let's head over to my office hours page. So this is the current session. And it has a little bit of information. And after the session is done and we process the video, it'll be available on this page. You can come back to this page anytime or pass it on to your coworkers who could not attend. And they can watch the video. Also, click on resources, and you'll see a list of links that you can use to follow up and get more detail on bulk processing. A couple of different articles, one by myself, one by Tim Hall, another by myself, and also one of the live SQL scripts that I'll go over today, which is how to convert from row by row to bulk processing, which can be a very non-trivial process and something you want to watch out for and do very, very carefully. And finally, though I won't run it right now, do check out this video, A Slow by Slow Start to the Day. It's a video by Connor McDonald, also a member of my developer advocate team and one of the AskTOM answer team along with Chris Saxon. And he basically put together a storyline of what row by row or slow by slow processing would look like in the real world as opposed to in our computer world. So check that all out. And again, you can always come back to this page in PL SQL Office Hours to get for a little portal on bulk processing and links to useful resources. Spread the word, get your coworkers to subscribe, and attend our sessions. There are many, many office hours to attend. Mine is just one of many. And the Office Hours program is all about opening up a big bandwidth of communication between you, our users, the most important people in our lives, and us, the internal experts who work a lot with this technology. So sign up for lots of office hours, take full advantage of the availability of these folks for this free online monthly trainings and how-tos. Oh, I guess I should go back to PowerPoint then. All right, so here's the question. What's the problem? Why do we even need to talk about bulk processing in the world of PL SQL? Aren't SQL and PL SQL super duper tightly integrated languages? Doesn't Oracle just take care of all this stuff for us? And the bottom line is that actually it does take care of a lot of this stuff for us, but we have to be a little bit careful about over-expecting from Oracle database, doing too much for us, because as you know, no matter how great the engine is, if we write our code poorly or design it poorly, it can run pretty awfully. So let's take a look at this piece of code. I would say that this is one of the top anti-patterns in PL SQL, something you see often, and it's something you should never see. And the bottom line, that what we're looking at here is a loop. Whoops, I didn't want to do that. Is a loop that has within it DML. So I've got a cursive for loop. I do some complex computations, adjust compensation. And then I update the employee, set in a new salary. So I've got a loop, and inside that loop, I'm doing individual DML statements. Now, the beauty of that block of code, because it's PL SQL, is that we can write that SQL statement natively. We can create these cursors and reference them in our cursor for loop. PL SQL makes writing SQL really, really easy. Perhaps a little bit too easy because we tend to take it for granted. So the tight integration between SQL and PL SQL certainly happens at the syntactic level. I can write a SQL statement, embed it right in my code. No JDBC layer, no string concatenations, just there it is. The downside is that maybe we take it a little bit for granted because we might forget that behind the scenes, of course, there's a lot of stuff going on and it's not always what we expect. So in this case, the main thing to be aware of when we're talking about the interaction between the PL SQL side and the SQL side is that there are two different engines in the database. There's the PL SQL statement executor, and there's the SQL statement executor. Now, when I run a PL SQL block, as I'm executing PL SQL statements, the PL SQL statement executor, as you might expect, takes care of those statements. But as soon as the PL SQL engine hits a SQL statement, it prepares that statement, all the bind variable values, and passes them over to the SQL engine. That's called a context switch. The SQL engine does its thing, sends the information back to the PL SQL block, another switch back. And those context switches are a source of bottlenecking in your database performance. And that's the key aspect around bulk processing, getting rid of or reducing to a minimum the number of context switches you experience in your code. Now, the other thing to remember, I'm not going to go into great detail here today, is that you can have the context switch the other way as well. So let's say you built a user-defined function that you call in SQL, a really cool way to extend the SQL language. When the SQL engine is running that SQL statement, let's say the select, it executes the PL SQL function, but to do that, it has to switch over to the PL SQL engine. Now, it's not uncommon, though it can be deeply problematic, that your user-defined function written in PL SQL has within it a SQL statement. So then you've got a select statement, switching over to PL SQL to run the PL SQL function, switching back to the SQL engine to run the SQL inside the PL SQL. Wow, lots of context switches. So be careful about that, understand that it works both ways, and very much take a close look at your user-defined functions. If you're calling a PL SQL function from SQL, it probably shouldn't have SQL inside of it, and if it does, you need to pay a lot of attention to the read consistency model that's involved there, because while the SQL statement will have read consistency and the block of code in which it's run, when you call that function from SQL, it's not a part of that read consistent model. So think on that one for a while. I'll keep going. Feel free to ask questions about it later as well. And by the way, as I'm going through my talk, feel free to put notes or questions in the chat. Probably not going to pay a lot of attention to them until I'm done with my little presentation here, but then we'll certainly be driving the rest of the session off of that. So type any questions or comments you've got into that chat anytime you want. Okay, so I can write this really nice syntactically integrated code with my SQL right inside my PL SQL. The problem is that I'm doing all this switching. So let's dive in a little bit more closely. Row by row equals slow by slow. So this is one of those very popular memes that Tom Kyte, the originator of AskTOM, and by the way, the TOM in AskTOM is now capitalized because it stands for Ask the Oracle Masters. We have a number of people working hard to fill in the big shoes left by Tom Kyte. But I think we're doing a pretty good job. So row by row equals slow by slow. The problem is that if you're switching back and forth with each DML statement, then you're incurring a lot of overhead with your context switches. So what you want to do is avoid the context switches. Well, how do you do that? Number one way to do it all in SQL. If you can run all your logic right inside your SQL statement and you don't have to switch back and forth, well, you're golden. No context switches. And in general, that's the path to take for an optimal application running an Oracle database. Do everything you possibly can in your SQL statements. Now, you can't always do that. There are two reasons you can't always do that, or at least two reasons you can't always do that. One reason is that you might not be able to figure out how to do it in SQL. We're not all Tom Kytes and Connor McDonalds and Chris Saxons and Kim Berg-Hansens and Stu Ashtons and Tim Halls, et cetera, et cetera. Another reason is that you may need behavior that doesn't match up to what you'll get when you run it all in SQL. And we'll take a look at that. So try to do it in SQL. If you can't do it in SQL, you can fall back on bulk processing with PL SQL. But do remember the classic optimization trade-off. This is true for almost any performance optimization you do. It's a trade-off between memory for CPU. You want to shave the CPUs, you're going to increase the memory you're consuming. And that's certainly the case with bulk processing, because bulk processing uses collections. And collections take up PGA, or process global area memory, per session memory. So in all the examples of code we're going to look at now, when we say bulk collect into this collection, populate the collection and push it through the FORALL statement, every one of those collections is taking memory out of your session. And if 5 or 10 or 20 people are doing the same thing, you multiply that memory consumption by 10. So if your collections get really big, you might have memory problems. but there are ways to manage the amount of memory you consume in the process of doing bulk processing. We'll take a look. So first, we're going to start with bulk collect. So bulk collect is basically the idea that you can retrieve more than one row with each fetch. So I say, get me some data, and you're not getting one at a time, you're getting a whole bunch, maybe 100, maybe 100,000 all at once. And the key thing here is that you could get an enormous amount of data from your table or tables, pop it into one or more collections, and blow out the memory for your session. So in general, what you want to do is fetch using bulk collect with a limit clause that you can use to limit the number of rows you get in each pass, and therefore the amount of memory you're consuming in each one of those fetches. Note that the cursor for loop automatically optimizes execution at 100 rows fetched per, or 100 rows retrieved per fetch. So assuming you've got your optimization level at least set to 2, which is the default, and you should probably kick it up to 3, then you don't have to worry about cursor for loops. They'll be automatically optimized. Regular loops in which you're, or explicit loops in which you're using an explicit cursor to fetch rows one at a time, those are not optimized. So let's take a look using Live SQL at some scripts using bulk collect. So as you may be aware if you've joined my sessions before, I've put a lot of my scripts on livesql.oracle.com so that you can not only watch this video, but you can follow exactly what I'm doing. You can download the code, you can try it out yourself, you can tweak it, use it in your own applications. Let's go. Over to Live SQL. So Live SQL offers 24/7 access to the latest version of Oracle database, 18c currently, and soon 19c, and then 20c. And you can write your own code here and play around with SQL and PL SQL. You can take tutorials, but we also offer a pretty large code library. So if I just put in bulk collect and do a search, I find a whole bunch of scripts. Looks like Steven's been doing a lot of scripting. They're not all my scripts. You'll see some by Don and Krishnaraja, David, but in any case, a lot of my stuff is there, and you can just go exploring at any point. When you've got a question about a particular aspect, here you go. So let's just dive into how to terminate a loop with fetch bulk collect. I'm just going to drill into the specific parts that I want to show you to demonstrate the feature. Bulk collect is relatively simple compared to a lot of others, compared to FORALL, so we're not going to spend a lot of time on it. But here's the basic idea. I've got a cursor defined at my package level, and inside my block of code, I'm going to open that cursor. And then I'm going to set my own loop up. So I'm not using a cursor for loop here. And I'm going to fetch bulk collect into with a limit clause. Now I could have avoided the cursor and avoided my explicit looping here and just said select bulk collect into my collection. The problem with doing that kind of unlimited bulk collect is if the table grows and grows and grows, at some point you could blow out the PGA memory for your session. So in general, the best practice when you're fetching with bulk collect is to use a cursor, explicit cursor, and then open and fetch. And then in your limit clause, which can be a constant, it can be a parameter, don't make it a hard-coded value. You don't have to change that value every time you need to adjust the memory allocation. But right here, you limit the amount of memory that's being consumed because you're limiting the number of rows fetched and therefore the size of the collection that's being filled. So that's the general approach you want to take. And then the key thing to remember is that when you're switching to fetching with bulk collect, don't check %NotFound right afterwards. That's what you would do if you were doing a single row fetch. But in general, with bulk collect, you want to check to see if the collection is empty. So it's anything that's in there before is thrown away, and it's replaced with whatever the latest bulk collect gets for you. And there are actually a number of different ways of terminating your loop with limit. This is my approach. I've got a few more here. Again, take your time, look through these scripts, try them out, explore them when you've got some time. But I won't do all of that right now. So that's an example of bulk collect and the important aspect of using limit. Okay. One other thing to just note here, you may be aware of the returning clause in SQL. So with a DML statement, insert or update or delete, I can say returning into, and I can get information back about the statement that was just executed. Really fantastic feature. If your DML statement, like an update, returns more than one row, what you'll want to do is say, where are you? There we go, returning and bulk collect into. So you can use bulk collect there as well. So bulk collect, fantastic feature for improving the performance of transferring data in bulk into your local collections, then massaging the data. By and large, you'll probably mostly be using it for bulk processing, obviously moving data sets from one table to another or one form to another, and in conjunction with FORALL. FORALL is much more complex, so let's get right to it so I don't use up my entire session with you just talking at you, talking. So FORALL is for repeated execution of the same DML statement, the same non-query DML statement: insert, update, delete, or merge. So the key thing here is to look for loops that contain non-query DML. If you still have a cursor for loop executing an update, insert, or delete, the bad news is it really shouldn't be there. You should have gotten rid of it a long time ago. Bulk collect, FORALL, and were added in PL SQL in Oracle 8i. But the good news is that that's low-hanging fruit. If you go back into an existing application, you can find situations where you've got performance issues and you've got loops that have DML inside of it. Your life's looking pretty good because you're going to be able to have an amazing impact on the performance of that code, and you're going to look really great to your coworkers and your manager. So look for those patterns. Sadly, our compile time warning subsystem does not currently find those examples of anti-patterns, so we can't help you there. You'll be doing it yourself. But you can use PL Scope to look for cursor for loops, to look for any inserts, updates, and deletes in your application, and then see if they're inside loops. So find those loops, and then ask yourself, hey, do I need a loop? Do I need a PL SQL loop here? Can I just convert it to simple SQL, or at least pure SQL? Sometimes it can be not very simple. And if you can do that, you're done. If not, or if you need something different from all or nothing, then switch to FORALL. Now, what do I mean by that? So I'd say there are roughly two cases in which you're going to want to use FORALL. Three. So sorry, one of them is you can't figure out how to do it in SQL. Number two is you've got to do some very complex processing using PL SQL procedural logic to massage the data, and you can't do it inside a SQL statement. The third reason you might want to go to FORALL is that SQL statements are generally all or nothing. So if I say insert select, and I've got 100,000 rows to insert, and I get to 90,000 rows, and then an error occurs, they're all gone. You can't keep any of them. Well, you could if you use log errors, but that's a whole separate discussion. In general, SQL statements are all or nothing. Now, when you're talking about this kind of bulk processing, I might be executing 1,000 update statements, all with different bind variables. And I might say that if any one of them fails, forget it. I don't want to do any of them, in which case the SQL approach is fine. But sometimes you say to yourself, wow, I got through 90,000 updates and I hit a bad update. Don't throw away everything else. Keep it, keep going. And then I'll go back and look at what went wrong later and fix it or log it or whatever the case may be. You can't do that in SQL. You can do it with FORALL. So that's one of the key reasons to use FORALL, is to have much more granular control over the error handling and the allowing to continue past exceptions that occur in your statements. And of course, as I mentioned before, FORALL is way more complex than bulk collect because you're changing data, which can lead to lots of different errors that you'll never get just selecting data. Let's take a closer look. So here's the classic formulation of FORALL. The basic idea is that it looks a lot like a numeric for loop. So for all instead of for, your implicitly declared iterator go from low to high value, and then inside that FORALL header, you have a DML statement. And somewhere in that DML statement, and it could be in multiple places, you have to reference your bind array and the index iterator. So there it is. And what I'm really doing is saying to the PL SQL engine, okay, you know what I mean. I don't want to loop through this stuff. I want you to bulk it all up, pass it over. You know what? I don't care how you do it, PL SQL. This is the behavior I need. So you're simply saying, take this array, stuff it into the update statement, do your thing. Don't bother me with the details. Declarative PL SQL. I love it. One of the key limitations on FORALL is it can only have one DML statement. So if I have a transaction with an insert, then an update, then a delete, etc., and I need to make that bulkified, that's a very complicated situation. And I'll show you an example briefly of the conversion process, and we can explore that in more detail in the questions and answers as well. But only one DML statement per FORALL. And the header, as you can see here, usually looks identical to the numeric for loop. And this is what probably 50, 70, 90% of your FORALL statements will look like this. But this requires that the array, this list of emps, is densely filled between low and high value, usually 1 to count. In other words, there are no gaps. If your collection is sparse, in other words, you've got the first row count is 1, the second index, the last index value is 15, nothing in between, only 2 elements defined, then FORALL will raise an error because it'll hit an undefined element in the array. So in those cases, you're going to want to either get rid of your sparse array, make it dense, or use indices of or values of, which I'll cover later. Okay, so some things to keep in mind with FORALL. So you got all these statements that you're executing. Let's say 1,000 different update statements are executed, or it's the same statement, but it's executed 1,000 times in the SQL engine. Or Oracle will, or the PL SQL engine will give you a new SQL% attribute called bulk row count. It's an array or a pseudo collection that gives you the number of rows modified by each individual statement. So for example, if your situation is that you're going to execute n number of statements, and if any of them do not find any rows, in other words, the update updates 0 rows, that's an error. You should always be updating at least 1 row per statement. You can actually iterate through this collection and find out if that was the case. Now, what if you've got those situations where you've got a lot of updates that you're running and you want to keep going through all of them, even if any of them fail? In that case, you want to continue past an exception, and you'll use save exceptions. And as I mentioned before, if you don't have densely filled collections, they're sparse collections or they could be sparse, then you want to take a look at using indices of or values of in place of that for loop, going from low value to high value. Another thing to keep in mind is that statement level insert triggers fire just once. So this is pretty similar to an insert select statement. So it's considered by the SQL engine to be one big insert statement, even though you're executing individual inserts. So if you have a statement level insert trigger on your table and you're switching from row by row to bulk processing, take a look at that trigger, make sure the logic still works if it's only running once before or after for the entire FORALL statement. Now that last statement there, my statement about insert statements, is the only difference I know in terms of the behavior on the SQL side when you switch from row by row to bulk. In other words, in general, what we're talking about here is changing the way the PL SQL engine communicates with the SQL engine. We're not talking about any changes on the SQL side. All of that is pretty much the same. The only difference here is that you might have a change in behavior on your insert trigger at the statement level. Back to live SQL. All right, so we took a little bit of a look at bulk collect, but we'll spend a lot more time in FORALL. If I look for FORALL, I've got a whole lot of scripts here. And again, I'm not going to go through all of these. I encourage you to try them out on your own. Let's start with insert performance comparison. So I put together this script to compare the performance of doing inserts, lots of inserts, either doing row by row inserts, doing a FORALL insert, doing an insert select from a nested table, etc., etc., etc. Here's the performance I found. For loop, row by row inserts, 100,000 rows, 6.7 seconds. FORALL, 100,000 rows, bulk, 0.196 seconds. That's pretty amazing. There are very few situations where you as a PL SQL developer can make a change just in your code and have this kind of performance impact. And when you find something like this, you really want to look for the opportunities to use it. Now you'll see a lot of other variations down below. And it turns out, at least in this run, the FORALL bulk collect was the fastest. But I'd say that the differences between some of these are so small that probably if you ran them several times, you'll see them kind of bubbling around each other. In general, I would expect insert select to be the fastest, but you can see that bulk collect operates really, really efficiently. Okay, let's just take a look through some of these scripts, give you a sense of what you can do. So explorations into, no, let's see. Oh, that's bulk collect. I want FORALL. Okay, so examples of FORALL statements. All right, so here's a FORALL with a delete. So there's my one to count. This is the most common format. And then I specify my array, and it finds those elements and does the deletes. You can have multiple bind arrays as well. So you just have to have the elements correlated between them. So it's not just for the where clause. You can also specify the values you want to be set in an update statement or insert, and so on. Don't keep going back to bulk collect. Let's take a look at save exceptions. This is probably one of the most critical aspects of working with FORALL. So if I just say FORALL, and I run my update statement, and I've got some potentially, for example, in this case, values that are too big for my table. If I don't have save exceptions, the first time it hits a bad statement, it raises an exception, and then you can trap the exception, obviously, if you want to or not. And what you'll find is that it'll tell you whatever the error is for that individual row. Okay, but notice a couple of things here. One is that, actually, I don't know why it says updated 214 rows. Because I got all the data from employees. Okay, so one thing to note is that when the exception is raised, let's say that I ran through 100 rows and I updated them and I got to the 101st and an exception was raised. Those first 100 rows have still been changed. You decide if you want to commit a rollback. So the raising of an exception on one of these statements does not cause a rollback to the other statements in the FORALL. It's different behavior than a single update. But if we add save exceptions, now what will happen is that we'll run through all the different operations, all the different statements for all the different bind variables without stopping. And then afterwards, Oracle will raise the negative 24,381 error. Now, negative 24,381 doesn't have a name, so I'm going to give it a name because I never want to say things like when others if SQL code equals. So I give it a name. And then in my code, I can check for the error by name, which is going to be really helpful for people coming along later and maintaining my code. It won't be so scary. It's obvious I'm catching the failure in FORALL. And then I can iterate through another pseudo collection called SQL% bulk exceptions. And this will give me the error index, which statement failed, and the error code. What was the error code? And I can now go through that array. And I can either log out the error to my actual logging table. I can try to do recovery depending on what the error is. I could say if SQL code is equal to negative 17, then try this. But generally speaking, you're going to take the contents of bulk exceptions, move them into your logging table, perhaps with the logger utility. Okay. So that's the basic idea behind bulk exceptions, behind save exceptions. Let's take a look at indices of and values of. And again, the idea here is not that you're suddenly educated about these features, but that you're aware of them and you can explore them further on your own. So let's go to indices of first. Now, indices of is helpful when you have a collection. Let's just move down here. That is sparse. So I have elements defined in 1, 100, and 500, but nothing in between those. And if I just say, hey, go from the first to the last, I'm going to get an exception because that row is not defined. So what I'm going to do is switch to saying, use the indexes in all the indices of this collection. And it's going to say, okay, I'm going to use 1, 100, and 500. And it updates 3 rows. Okay. So if your collection is sparse, you can switch to indices of, and it will simply look through that collection. Now, in this case, this is the simplest case. I've got a bind array, and I'm using the bind array as the reference in my indices of. But, and hopefully I've got the more interesting example, yes. You might have a situation where you've populated a collection with 100,000 rows of data. And then you have different algorithms that determine which of those 100,000 elements in the collection I want to use in my DML statement. And it could be different for every run. So I have a separate collection in which I run the algorithm that populates whether or not this is an index that I want to do the update on. So basically, I'm constructing my list of valid indexes for my DML statement. And then notice, my bind array is different from my indices of array. And it's going to cherry pick out of this list, whatever indices are defined, it will use as the index value here. So that gives you a level of indirection and sophistication for very complex algorithms. And alternatively, if I look at values of, I'd love to hear, by the way, chat, we can unmute you. If you've used values of, I'd love to hear about it because I've never heard of anybody actually using this. And I see I've got some chats coming in and we'll take a look at those in a moment. Values of is even more indirect. In this case, you're looking at the values in the array, not the index value, not the indexes. So I'm populating my array with the index values in the bind array that I want to perform my DML on. So negative 77, 1367, you can see this, but I'm skipping over this one. And then I reference that in values of. So really, indices of looks at the index values of the array you specified. Values of looks at the values of the elements in the array. So let's finish up by talking about refactoring to bulk processing. This is tricky stuff, which means it's really good time to get a drink of water. So you found a loop with DML inside of it. What do? What you could do is say, oh, this is really exciting. I'm going to read a couple of live SQL scripts and dive into my code and mush it around and change everything, and it's going to be perfect. I don't know about you, but I'm really bad at writing perfect code. And in this case, again, you're talking about changing code that modifies data and modifies it in bulk. It's a pretty important piece of code, likely. So you could really screw things up. Here's what I suggest you do. Before you make any changes to your code, carefully, completely document its current behavior having to do with the DML statements. For example, what happens when an error occurs? Do you stop? Do you trap the exception and keep going? Is it a complex transaction with multiple statements? How do they relate to each other? When do you commit? When do you roll back? All of that stuff needs to be documented clearly. And then, if you're a really, really good person, you'll build a regression test to prove later on that the new, faster approach not only is faster, but it's actually correct. It behaves in the same way. Now, building regression tests for back-end programming for database programs is not trivial. There are a number of frameworks out there. There's the one that I was originally involved with called UTPL SQL, wrote it back in 1999. It's now been resurrected in a brand new form using object orientation. Really cool stuff, UTPL SQL v3. Check it out. SQL Developer also has integrated unit testing built into it. Look at all these options, but don't take a piece of code that's mission critical, that's modifying your data, and just think you can change it to the extent that you're going to change it with bulk processing and everything's going to work. Chances are you're going to have a lot of headaches. So you've done those things. That's great. Then what you want to do is go through the conversion process. Now, what I'm going to do is finish up my presentation, and I'm sorry it's going on this long, and show you the basic steps of a non-trivial transformation for bulk processing. We won't be able to cover all the details. Maybe some of the issues will come up in the Q&A, but I do want to make sure we've got time for that. And really, this is the sort of topic that you'll want to really sit on and think about for quite a while, both in terms of my script and your own code. Let's take a look. So when you're moving to bulk processing from row-by-row approach, what you're doing is moving from an integrated row-by-row approach to a phased approach. Very different. So the interesting thing is that row-by-row can be too slow, for sure, but it also has some advantages, especially when you're talking about a multi-DML transaction. I'll show you that in the code in a minute. But the basic idea when you're doing this conversion process is you're going to start with one or more relational tables, usually, and you're going to use bulk collect to take all that data and move it into collections. It could be one collection, it could be a dozen collections. It could be that you're not getting data from tables and it's coming from a file or it's input into your program. Whatever the case may be, you're going to build that set of collections. And then phase two, and it's not always present, but most likely it will be for the situations where you can't use SQL, is that you're going to modify the contents of the collections according to your requirements. In other words, you're going to run some algorithm against those collections to modify the data, get them all ready. And then phase three is when you're going to take FORALL and push the data back to the table. So my general recommendation is that you keep your FORALL statements really clean and simple. And the idea is not to do a lot of computations inside the SQL statement at that point. Get it all done in advance in your collections and do a simple push back out to your table or tables with FORALL. Okay. So that's the phased approach to keep in mind as I go through this code with you, because it has an enormous impact in terms of the complexity of the code that you're writing. So I'll bring that back up. Yes, 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 yes. Back to live SQL. Okay. So here's the situation. Here's my before version. I've got a cursor for loop, and inside my cursor for loop, I've got a block of code. And I'm going to insert into my history table. This is a pretty dumb example. There are better ways of even doing things like logging previous values, but just bear with me for my relatively simple example. So I've got my table that I'm inserting into. Then I'm going to run some complex calculations to calculate what your new salary should be. And then I'm going to run an update statement. So I've got two DML statements. And then inside that, they both occur inside this begin end block. And so what's going on here is that if anything goes wrong with an insert or an update, I'm going to log the error and keep going. And in particular, if the insert fails, the update never happens. So keep all those things in mind, and these are the kind of things that you want to document when you're building out your code. Okay, so the after version. The first thing I want to show you is that this is, maybe like 30 lines long. It's very concise, but it's got this problem of context switching. Here's my after version. And this is probably pretty close to what you would do for production, but it's probably not even fully there. Wow, that's a lot longer. So this is one of those situations where you're going to take advantage of a new feature in PL SQL. And it's not going to make your code smaller and simpler and so on and so forth. Sometimes that happens. Not in this case. In this case, what you're talking about is an expansion, a pretty significant expansion in the complexity and quantity of your code. But when you can go from 60 minutes down to 1 minute or less, it's the sort of thing you're ready to pay the price for. Let's take a look at the basic elements of the conversion. So here's my cursor for loop. If I go down to the bottom of my long procedure, here's my main executable section. So I'm taking advantage of what are called nested subprograms to make this really readable. So I've got a cursor. I fetch n number of rows at a time using a parameter to control that, so I can change the value without changing my code. So I get my first 100 rows, whatever. I stop when there's nothing left. Now here's my phased approach. I insert, I do my adjustments, and I do my updates. Let's take a look. So we don't have to worry about the adjustments program. That's whatever your application is doing. Really complicated stuff. Here's my insert. So I've got a FORALL statement. I've populated that list of employees that I'm about to change. Now I want to save their previous history. So I simply insert into the employee history table for those values. Notice I've got multiple fields from the same collection of records. This is something that you could do as of 11.2. And I say save exceptions. Okay. So I trap when something went wrong, so at least one insert didn't work. Now my problem is that I have to somehow communicate from phase 1, or this first part, to this phase down here. In other words, in this phase, one of the inserts failed. In the original code, that meant that the update wouldn't happen. How do I tell the update coming later in bulk that the insert failed? Let's take a look. Again, this is going to be to some extent application specific, but you need to be aware of the issues here. Now what I've done here is saying, let's go through my SQL% bulk exceptions array, log the error so we know what happened, and then delete from my exception that row in the collection. You can't update it if it's not there. Now again, your recovery, your mechanism of communicating from one phase to the next in a multi-DML transaction may differ, but it could be as simple as simply getting rid of it. Okay, so I got rid of any of the rows in my original table that could not do the insert. But now I've got a problem because my collection may no longer be densely filled. I can't just say, hey, go from 1 to the count. So in my update program, my FORALL statement now says, use only the remaining indices of the employee's collection. So if I got rid of it, I'm not going to see it, and it's not going to cause a problem. So then I do my update with the new salary. I save exceptions again, and if anything went wrong, I go through that array and I log the error. So those are the basic steps that I went through to do a non-trivial starting point of multiple DML statements, the need to communicate between them, the use of save exceptions and indices of as a result. This probably doesn't handle all the complexities. For example, even in this code, I don't really know what to do if the update fails. Well, if the update fails, the insert isn't rolled back. Probably we want to do that. In any case, you can see that there's probably more to do, but also that this should be a good, simple example that can help you figure out what the impact is in your code, what things to look for, and what kind of transition in code you need to make from this kind of elegant, concise row-by-row approach to the phased approach of bulk processing and the attendant issues that can show up. Back to PowerPoint. So that's the end of my presentation. I have one question that came in advance, and I've got some other questions that we'll now take a look at. So, but let's first take this question. Some of you might have some ideas for me as well. So how do we demonstrate to developers that bulk collect is more effective before actually running it? Something like comparing an explain plan with and without bulk collect. This is a pretty interesting question. So first of all, please remember, The explain plan is not going to change whether you're using bulk collect or not, because it's not changing what's happening on the SQL engine side of things. All it's doing is changing the way that the PL SQL engine is communicating with the SQL engine. So that's not going to help you. Here's one thought. Turn off optimization and rerun a cursor for loop, and you can show them the difference there. And I believe I've got a live SQL script. Now I do want bulk collect. Oh, thank you so much. And I think right at the top, automatic optimization of cursor for loop. So here's a script in live SQL that shows that when you reduce your optimization level, for example, if I turn optimization off, notice that my cursor for loop is about the same as my explicit loop, while the bulk fetch is much faster. If I turn optimization back on, now my cursor for loop runs in about the same time as the bulk fetch. Now, they could argue that that's not a compelling answer, even though you didn't write any of your own code. But I think that's pretty significant, and it shows that when you have optimization turned on, cursor for loop runs like bulk processing. It actually doesn't turn it into a bulk collect, but the similar thing underneath in the OCI layer. But it does show the difference in performance between bulk versus row by row. So that I would take them to that live SQL script and show them that. The other thing, though, is that developers should understand enough about the database architecture that you shouldn't have to do something like compare explain plans. They should understand what a context switch is. It's critical they do understand what a context switch is. They should understand the impact of using collections on PGA memory. And once they understand those things, the architecture behind this should be pretty clear and compelling. Okay, so that's the one question I had in advance. Now I've got a couple of long statements here, and I'm just going to read them to you because it's hard to read it silently first and then read it out to you. When we use bulk collect FORALL approach, we first load some data from our tables to collections. We do the work and then upload the data back from collections to tables. Even more, when using FORALL, the number of DML queries is as big as when we use a traditional for loop and a DML query inside. But instead of all of this, we could use a global temporary table for the staging data instead of populating a collection, then do our job, and we could upload the transform data back to persistent tables using a single merge operator. I find this approach a bit more efficient, using only 3 SQL queries which are well optimized, and we can even add an index on a temporary table. Are there any advantages of bulk collecting FORALL approach which I'm missing? Maybe an exclusive use cases where this approach just shines. Well, Dennis, I haven't used global temporary tables in a while. I remember running some tests a while ago. Maybe it's changed in recent versions, but I found that using collections was still markedly faster than global temporary tables. The bottom line is you're still using SQL. So it sounds like you had a good experience and your performance didn't suffer, so that's great. And maybe my recollection and my previous tests are not good measures. But it seems to me that, number one, the advantage of using global temporary tables is you can stay within SQL, and you're not using PGA memory, I guess, at that point. But you still run into the issues of the SQL PL SQL context switch, and you still run into the issue of managing the DML statement in terms of being able to use save exceptions to trap failed statements, and then recover or continue. Another one from Dennis. You tend to use FORALL statements when it comes to loaded collection data into a database table, but can you mention pros and cons? If you compare this approach to usage of table operators on schema-declared, nested table collections, or associative arrays, this gives us a SQL interface on it, and we can integrate its usage into another, more complex SQL query and process our data with all the power of it. Great point, Dennis. So you can use, when I do it, here, let's go back to my insert select. Let's see. So what I wanted to show you here was referencing this table right, my insert performance. So let's go back to FORALL. Inserts performance comparison. Here's what Dennis is talking about. So what I've got here is a nested table that I've constructed, and I'm doing an insert select from table of that nested table. So this is another way that you can not use the FORALL statement. I can have data inside my collection, but instead of doing a FORALL statement, I can simply say select star from table of that collection, and that will convert it into a relational table format. And then you can not only insert into, but you can join with other collections and so on. This is something that's covered a lot in my session last month on table functions, though in this case there's no table function involved, it's just a nested table, but the same principles apply. So it seems to me, Dennis, that we have the same situation here in that there are advantages to putting data into the nested table and using that with the table operator as a selectable object, as a SQL object in a sense. What you lose is the granular ability to manage exceptions, for example, with save exceptions, that you don't get here. So this is an insert select. No ability to say, I only want some, if any of them fail, keep going, all that sort of thing. I would think that that's one of the main differentiators in this case. And from Nils, usage of values of. When you have one collection with records to be updated, inserted, or deleted in a table, you can use a second collection to first store the indices of the records to be updated. And then process it with for all values of update. Store the indices of the records to be inserted and do the for all values of insert. And at last store the indices of the records to be deleted and do a last for all values of delete. Okay, so that's another example of a use case for values of. Thank you, Nils. That's great. Okay, so other questions or comments? That covers everything I've seen there. Anybody else? Anybody want to share their experience with FORALL and BULK COLLECT? While you're thinking about it, let's go back to the Dev Gym for a moment. Haven't gone there yet. So the Dev Gym is a website where you can take quizzes, workouts, and classes on SQL and PL SQL topics and even Java. One of the things you can do is go to workouts and say, you know what, I want to do one of my do-it-yourself workout on performance. So click on do it yourself. Let's DIY workout. Select performance. I'm going to go for an hour. Take any level of difficulty, and it will create a workout for you from all the quizzes that we've been writing over the last 8 years. And here we go. And you can see there's a lot on FORALL, sparse bind arrays, restrictions on usage of, and some other things as well, bulk fetch. So what you can do is go to if you're not already using the DevGym, go to devgym.oracle.com, check out our weekly quizzes, our classes, etc. But what you can also do is drill down into workouts and create your own workout, or, so that's do-it-yourself workout, or go to all workouts, and then you can do things like find PL SQL, and you'll find that we have a number of workouts already created. For example, BULK COLLECT, which is actually based on some of Tim Hall's articles. So he's written, as I'm sure you know, the oraclebase.com site, tons of articles on all the different features of Oracle database. We've taken those articles, put them together with quizzes that we've already created to give you a workout based on his teachings. So there's a lot to check out in the DevGym regarding increasing your expertise and awareness of FORALL and BULK COLLECT. Let's see, we've got a couple of topics here. The trick with usage of temporary table from Dennis is that you process the data with the power of SQL. Actually, you can log errors in SQL when you use the log errors directive in your inserts and updates. In this case, the exceptions are logged into a special table. So yes, great point there, Dennis. So Dennis is, I think, making a strong argument for relying as heavily as possible on SQL. No disagreement there. And he mentions log errors. So let me take a look at that for just a moment. We'll go back to Live SQL. We'll search for log errors. So the idea behind log errors is that you can suppress DML errors at the row level. And I'm emphasizing that because that's different from FORALL and save exceptions. So the idea here, not to go through all the details, is that you can create, let's go back up here. You can use DBMS error log to create an error log table for the specified table like employees. And then you can change from the all or nothing model, which I talked about before as being the dominant model for SQL. So all or nothing means that if any of here's my update, I'm going to give everybody an enormous salary. And if any single employee can't accept that level of salary, in other words, salary gets too large, then everything's rolled back. Every single row change in this update statement is rolled back. Now, what you could do is add log errors to your update statement. In this case, I'm saying, I don't care how many go wrong, just keep on going. And that means that this update statement will always complete without errors. The kind of errors that you'll get trying to change a row. There are other errors, I'm sure, that will cause it to fail. And by saying this, what this will do is allow you to do essentially a partial update. So now I've updated 49 rows, whereas none before were modified or had this higher salary. So that's what Dennis was referring to. You could switch to global temporary tables. You've got the context, and if you can do it all in SQL, you don't have context switches. And if you have a concern about losing data, stopping the SQL statement too soon, you could use log errors. There are a couple things to be aware of. One is, or the differences between save exceptions and log errors. With save exceptions, if something went wrong, if even one row had a problem or one statement had a problem, an exception is raised in the PL SQL environment. When you use log errors, an exception is never raised. So you have to make sure to go back and check the error log table after you use log errors, which no big deal. You just have to remember to do it and put it in your code. Similar to the loop through bulk exceptions array, you'd have a loop through your error log table and probably transfer the data from your log table to your generic application error logging table. So that's one big difference between the two. The other one, which is bigger, is that log errors is all about suppressing errors at the row level. Save exceptions is about suppressing errors at the statement level. So again, it could be that you don't care about the difference, and you're going to go ahead and use global temporary tables and pure SQL and log errors. But there's a big difference here. So if I'm executing 100 updates, let's go back to FORALL. So here's my update statement. Now this is a single row update. So in this case, it really doesn't matter. You can use log errors, you can use save exceptions. It's always going to be a single row. But if I have an update that's modifying potentially more than one row, then the behavior that you get from log errors could be very different than the behavior you get with save exceptions. With save exceptions, the statement will fail and you go on to the other updates. With log errors, you'll be doing a partial update on the rows for that given where clause criteria. So keep that difference in mind. From Mark, do you have any examples of converting nested for loops? I have one old job doing a Jaro-Winkler comparison, writing out to a third table that looks right for this type of optimization. I do not have any examples, Mark, of a nested loop using FORALL and BULK COLLECT. I'm not sure what we'd have in that nested for loop that would be particularly significant from the standpoint of the bulk processing statements, because you're going to have a loop, and then I suppose some DML inside of it. You might have DML in the outer loop, DML in the inner loop. You know what, Mark? It's application specific. There, it depends. So I'll give that some thought. Maybe you can communicate, get in touch with me afterwards, and we might be able to work up a clear use case that's general enough to build a live SQL script around that people could then utilize. But I don't have any insights right now about what would be different there. If you have more thoughts right now, feel free to type them in. And from Dennis, another way to log errors in SQL is to use a special subprogram for this with Pragma Autonomous Transaction switched on. And as Eric Olson says, just use logger. So another way to log errors in SQL. Dennis, I'm not sure how you would be using your special subprogram in SQL, because you're going to be called, that's a procedure that's being called. But just to make sure you folks all know about it, he mentioned autonomous transaction. So let's go take a look at that. Again, let's first see what we've got in Live SQL. And a very basic error logging package. There we go. So what Dennis was talking about is calling a procedure like log error that will write your error information into a table and save it. And his point here is that what you want to do with this kind of utility is make sure that your error logging procedure is defined as an autonomous transaction. And what this means is that you can do an insert, an update, delete, etc., and then commit. And in fact, you have to commit or roll back. But this commit will only save the changes made in this one procedure, not in your entire session. So that gives you the ability to take that error logging information, write it out to your log table, save it, and then continue with your processing. But I'm not sure how you would do that in the context of a pure SQL solution. That certainly makes sense, even with save exceptions. This is the kind of program you should call when you're logging the errors in the save exceptions error handling block. And it was Eric who mentioned logger. So just so you know, if you don't already have a generic logging utility, something like this, go to oraopensource.com and check out any number of these open source utilities, but certainly check out Logger. It is probably the most popular open source utility for error handling and execution tracing for PL SQL based applications. And it's a really nice utility, and you should check it out. Certainly, it doesn't make sense to write your own, as I did not too long ago. Well, 10 years ago. And Dennis follows up, I meant that this really depends on the processing. Most of the times processing is done in PL SQL. And in this case, one can use just such a logging function. Absolutely correct, Dennis. Thank you for pointing it out. That without question, when you're writing this code in PL SQL, you definitely must log your errors. When you log your errors, you should use a generic reusable utility, and Logger is a great choice to go with. Other questions or comments? Oh, no more questions or comments. What do you know? It's 9:57. That means that it's time to end my latest office hours session. I hope you've enjoyed it, gotten a lot out of it. In fact, I'm just going to stop my share so I can talk to you in big mode. So thanks for joining me for this latest office hours session. I hope you got a whole bunch out of it. We'll get the recording up really soon. You can share it with your coworkers who couldn't make the session. Please let me know if you have other ideas for topics in the future. We'll be doing these. I do these on a monthly basis. And in general, do get in touch with any questions or comments you have about the PL SQL language and help you need on it. We are here to help. Thanks very much. See you next month. Take care, everybody.